welcome back to Webjo versus YouTube channel where curiosity meets the code. Today our topic of discussion will be what are training datasets and what are testing datasets, what are the difference between these two. So let's get started. So firstly we'll be going through introduction to datasets, then we are going to data and the machine learning pipeline. I'm going to introduce you to training and testing data, strategies for acquiring the data, which is a balanced act, data cleaning and pre-processing, feature engineering, class balance and stratification, which ensures a fair representation. Then we have the training data best practices. Then we have benefits of best practices, testing data and model evaluation. Then we have real world data sets, which is fueling diverse model. Then we have beyond basic testing, which is advanced evaluation strategies. Next, what are datasets? A dataset is a collection of data points used to train and evaluate machine learning models. These data points can include various types of information such as text, images, numbers, and sensor readings. The quality and diversity of the dataset significantly impacts the performance of the model. Next, what is the data and machine learning pipeline? So you can see there is a step-by-step process you need to follow. Firstly, we have dataset building, then we have dataset pre-processing, choosing the appropriate technique, training, evaluating, and deployment. So this is the pipeline for data and machine learning. The series of steps involved in building and deploying a machine learning model. These steps typically include data collection, cleaning, feature engineering, model training, model evaluation, and model deployment. Next, this is a small introduction to training and testing of the dataset. So the entire dataset, there is a complete dataset, and 75% at random becomes the training dataset and remaining becomes the testing dataset. How these two will be used will be seen in further. So firstly, the training data set, which is 75% of the data, of the complete data, the portion of the data used to teach the model to recognize patterns, make predictions. The purpose is to provide example for the model to learn from and analyze, adjust its internal parameters. Then we have the testing data set, which is 25% or less, the portion of the data held out for training used to evaluate models' performance on unseen data. The purpose is to access the model's generalization, ability to prevent overfitting. What are the key differences in both of them? Training data is used for learning and testing data is for evaluation. They must contain different data points to ensure unbiased evaluation. Next, what are some of the strategies for acquiring data? Firstly, we have web scraping, explain the process of extracting data from the website, highlighting popular scraping tools and libraries, discussing the importance of respecting robots.txt and legal consideration. Then we have APIs to collect the data from, which is public and private APIs are structured data sources, emphasize the need for understanding the API terms and conditions, briefly mention the authentication and authorization protocols. Then we have surveys and questionnaires. This explains the benefits of collecting the data directly from the targeted audience, discuss different survey platforms and design principle. Then we have emphasized informed consent and ethical data collection practices. Next, what is the data cleaning and pre-processing steps? So firstly, data cleaning and pre-processing are critical steps for transforming raw data into distinguishable format for machine learning models. It's like refining raw ingredients before cooking a delicious meal. Why it is important? Firstly, we have image training your model on data riddled with errors, inconsistencies, and missing values. The results would be unbearable and misleading, just like a recipe with incorrect measurements. Then we have cleaning and pre-processing ensures accurate, reliable model prediction, which is clean data leads to better understanding and more trustworthy outcomes. Then we have efficient model training without struggling with messy data. Models train faster and coverage smoothly. Then we have improved model interpretability. Define the data allows us to understand why behind our model's decision, foresting, trust, and transparency. Next, what are some of the key techniques used in these both? First one is noise removal, eliminating outliers, typos, and irrelevant information. Thinking of removing moldy vegetables from foreign objects that your dish has. Then we have imputation, filling in missing values intelligently with substituting a forgotten piece with a similar one. Then we have standardization, scaling features to a common range, ensuring all ingredients speak the same language in the model's recipe. And then we have transformation, converting data into suitable formats like chopping vegetables or grinding spices for easier mixing. Next, we have feature engineering. So, feature engineering is the alchemy of transforming raw data into powerful information features. It's like sculpting clay into intricate bricks, each holding more meaning for a model. Techniques can include, firstly, we have combining features, we have creating new features from the existing one, like calculating time since purchase from the date and purchase date. Then we have feature scaling, which ensures all features speak the same language, like standardizing measurements for building materials. Then we have dimensionality reduction, we have compression data while preserving key information, like choosing the right load bearing walls for your building. Next, we have class balancing and stratification, ensuring fair representation. To ensure that all the voices are heard and all perspectives are considered, we can employ several techniques to address imbalanced data set. Oversampling, the first one, empowering the minority voice, which is image given the 5% struggling extra tutoring, and support the amplify their voices and ensure their perspective are not overlooked. And then we have in machine learning oversampling techniques like smooth, which is synthetic minority oversampling techniques, achieve a similar effect. They replicate minority class instances to create a more balanced dataset, giving the underrepresented voices a stronger preferences in the learning processes. Next, we have to do undersampling. This is spotlighting the underrepresented. Imagine holding a focused discussion group only with 5% of the struggling students, allowing their unique challenges to take center stage. Sampling statistical removes instances from majority classes to reduce imbalance. While this can potentially lead to information loss, it also creates a more focused learning environment for a minority class. The third one being stratification, fair representation in evaluation, which is imagine diving the class into smaller group of activities, ensuring that each group has a balanced mix of both expert and the struggling students. Then we have stratification applies the principle to cross-validation to maintain balanced class representation within each fold, ensuring that the model performance is evaluated fairly, not skewed by imbalanced data distribution. Next, what are some of the best practices in training data? We have firstly version control like tracking rockets, blueprint, use Git or SVN to track changes in your data, enabling rollbacks in collaboration. Then we have comprehensive documentation, document the data sources, cleaning step, transformation and ethical consideration. Think of it like it is a detailed flight plan for your rocket. Then we have secure storage and access control. Use strong encryption and access controls to safeguard sensitive data like securing the launch pad fuel tanks. Next, we have reproductivity and collaboration, version control and documentation enable efficient collaboration and ensure models can be reproduced by others. Then we have reduced error and risk, secure storage, minimize the data breaches and ethical consideration, prevent discrimination and unfair outcomes, ensuring a safe and ethical launch. Then we have trustworthy AI models by using ethical sourced and responsible managed data. You build models that are reliable, fair, and contribute positively to society. Next, what is testing data and model evaluation? Testing data is launchpad for understanding its true performance and generalized capabilities. There are types of test data. First one is hold out the simplest option but prone to bias with smaller data set, and imagine splitting the fuel tank into half for testing, leaving less for the launch. And then we have cross validation efficiently utilizes all data by dividing into smaller folds for training and testing, providing a more robust evaluation. Think of testing the rocket engine in a smaller burst before the full launch. Then we have the k fold cross validation, a specific type of cross validation where data is divided into k equal folds, offering even more reliable estimates. Imagine testing the rocket engine across the multiple launch simulations. Then how do we choose the right test set size? Firstly, we have formula or table. Include a formula or a table showcasing the relation between data size, test set percentage, and evaluation accuracy. Then we have bias concern. Discuss the potential for bias in the smallest test sets and how it can impact the model performance. And then we have resource availability. We can emphasize the importance of considering available resources, which is computing power, storage, when determining the test set size. Next, we have preventing data leakage and overfitting. Firstly, how do we do that? Firstly, we have concrete example, illustrate the data leakage and overfitting with real world scenarios or case studies relevant to your audience. Then we have detecting techniques, briefly mention the techniques used to detect the data leak and overfitting, example stratification, early stopping. Then we have impact on performance, show the impact of data leakage and overfitting on model performance through graphs or chart. Next, we have evaluation model preferences. We have confusion matrix. Introduce the confusion matrix to the tool for visualizing different evaluation metrics for imbalanced data sets. Domain specific matrices. Discuss any domain specific metric relevant to your field or chosen project. Then we have model comparison, which showcases how evaluation metrics can be used to compare different machine learning models for some tasks. Next, some of the real world data set fueling diverse model. We have MNIST, which is handwritten digits. Firstly, simplicity and uniformity. MNIST primarily features clean and uniform digits, lacking the diversity found in real world handwriting. This specificity might lead to models to struggle when faced with complex, varied writing styles and conventional digit formations. Then we have lack of context. The data sets lack the contextual information about the digit, such as the position of the digit in a larger sequence or a context of the surrounding characters. This absence make it challenging for the models to grasp at the intricacies of the real world scenarios. Next, we have ImageNet. So this is used for image classification, representation imbalance. Despite its extensive coverages, ImageNet tends to have representation imbalances across different categories. This leads to overfacing common objects and understanding rare ones, affecting the model's ability to generalize or to less common images. Then we have cultural and geographical biases. ImageNet reflects cultural and geographical biases as a majority of the images come from certain regions and demographics. This can result in model being less effective when applied in diverse global data sets. Next, we have OpenAI 5, which is StarCraft AI. This is imperfect information. Real-time strategy games like StarCraft involve imperfect information where players don't have complete knowledge of the game's stat. This challenge AI model to make decisions based on incomplete data, requiring adaptability and statistical thinking. Then we have dynamic and unpredictable environment. StarCraft dynamic and unpredictable environment influenced by a player's strategies introduce complexity. AI model must continuously adapt to evolving conditions, showcasing the necessity for flexibility and rapid decision making in the real world applications. So beyond basic testing, some advanced evaluation technique, we have transfer learn, transfer knowledge. Transfer learning involves leveraging knowledge gained from a pre-trained model on one task and applying it to a new related task. This accelerates training and performs improvement. Secondly, we have rapid adaptation. By transferring knowledge, models can rapidly adapt to new tasks, reducing the need for extensive training on large data set. Then we have enhanced performance. Transfer learning often leads to improved performances, especially the scenarios with limited labeled data, as models inherited valuable features learned from prior tasks. Next, we have retained models. We have BART for NLP and RSNet for image recognition. Showcase industry leading models like BERT and natural language processing NLP and ResNet for image recognition. Foundation for various applications. Then we have versatility. Highlight how pre-trained models serve as a strong foundation, providing a starting point for various applications across different domains. Then we have knowledge transfer. In this case, the ease of knowledge transfer as from well-established models to specific tasks, reducing the need from training from scratch. Next, we have an assemble learning. This introduction to the concept combining multiple models. And assemble learning involves combining prediction from multiple models to produce a more accurate, robust result. The advantages and performance enhancement, which improved accuracy, showcase how an assemble learning helps to mitigate individual model weaknesses and enhance overall accuracy by leveraging diverse perspective. Then we have robustness, discuss how unassembled models are more resilient to outliers and uncertainties and contribute to improved robustness in real world scenarios. This is it for today. If you have any queries, leave it down in the comment section below. Thank you so much for watching. If you have learned something from this video, please do like, share and subscribe to our channel. Thank you.